Hi guys, it's Mr. Corzine. I wanted to go over these notes with you for section 5.6. Just reviewing some things about scatter plots and fitting a line to data. We now have the skills to write an equation that fits data on a scatter plot. So we want to practice doing that. So let's look at our first example. First thing about scatter plots is you can have your information going uphill like this. That's the points on your scatter plot are not exactly following that line, but they're in and around that line, and you can see the trend is going up like this. This is a positive correlation. In the opposite direction, when your points are going down or trending down like that, that's the negative direction. I don't think you guys would have any trouble understanding that. But then there are other times when the points are more random. You don't really have a way of predicting where the next point is going to go. Because of that, we'll just say that there is no correlation. So moving down here to the bottom, they're asking you which of these scatter plots, A, B, or C, is the best for making a prediction. Like which one would give you the most confidence where you would know what's coming next. Obviously, this one is out because it's pretty random. These two they're both pretty good. You can see this one is like going down like this one's going up. But I would say this is the best one because the main reason is the points are tighter. And because of that, we get a closer or a better trend. It's easier to tell what is the next possible point because they're all so close. Now, you could make an argument that this one is just as tight, except for we've got this outlier here, and that outlier just leaves some doubt in your mind about what may be coming next. We don't really have any outliers in this one. Really the meat of this lesson is about line of best fit, or being able to put in a trend line. Whenever you have points on your graph, you can see, like you can imagine a line is going there, but then if you want to make predictions about the future, you might actually make a line and say the rest of these points are going to be in and around this line. And so that takes a little bit of work. First of all, the trend line that you draw, which it won't be there until you draw it, it should be as close to all the points as possible. Okay. The other thing is it should split your points, all of your data, into two pretty even sections. So this is a great line. This line follows the trend the best possible way. And it also has about the same number of dots at the bottom as it does at the top. And it can go through some of these points too. Some of the points can be on the line. One of the big mistakes that I see people doing is I see people doing something like this. They draw a line, and the only thing that they're concerned about is cutting the two groups in half. That's not really it. You want to make a line that fits the data, that goes along with the data, not against it. You're not trying to chop the group up into parts. So I would get rid of this. That's no good. Okay, so now we're going to make a judgment. We're going to look at these three lines right here. Which one of these is which one's the best, basically? I see this red line right here that chops it in half, but it doesn't really go along with the data. I see this purple line right here. It goes along with several of the lines really well, but again, it's not real close to my other points. But then I have this one right here, this green one. That one fits. It goes along with what the points are doing, and it's really close to everything, the best it's we still have, if you look, we still have like these outliers out here, and they're just not going to follow the trend. They just don't work. But that's okay. This line is your best one. Now, when it comes to making your own line and writing an equation for it, the toughest part, there's several steps, and I'll kind of walk you through that. First of all, the toughest part, this is the one that you have to practice, is you have to identify 2 points on the line. Okay, so you make your line, and the line has to split the group and be as close as possible, but then you want to be able to identify a couple of points on there so that you can write an equation. So here they've picked out 2 points. You've got 2 and 20. See this? 2 and 20, and then 6 and 40. 2 and 20, 6 and 40. Once you have those 2 points, you basically can write an equation of a line. We've already learned that. If you have 2 points, you can find the slope, you can find the y-intercept, you're in great shape. So if you find the slope, you're going to do y2 minus y1 over x2 minus x. So this is 40 minus 20 over 6 minus 2. So you get 20 over 4, which ends up being 5 over 1. That's your slope. Okay. Then you want to find the y-intercept. You might think that might be tough, but it's not. I look right over here. Where does that line that you drew, that you made, where does it look like it's going to cross? Well, it looks like it's going to cross at a positive 10. After that, you write your equation. Instead of y equals mx plus b, I can plug in my slope and my y-intercept. And what I get is y is equal to 5x plus 10. And this describes basically the trend of these points. Are all my points going to be on that line exactly? No, but this is y equals 5. That's what I'm looking at. That's a way to describe what's happening in the scatter plot. So here's another challenge for you. You have a line of best fit. They've drawn it for you. And so they've kind of split it into 2 groups. They've drawn it as close as they can. You see how it goes through several points here. It works out really well. But you have to go through the steps. First one is find 2 points. Okay. I need to look on here for some good, firm numbers, the best ones that I can. So I'm looking along here, and I'm trying to find a place on my whole numbers for my x values. And it looks like I can do something like, let's see, I can do 3 and 16. That looks pretty good, right? 3 and 16. 3, 16. And another really good one, or I could do 4. Oh, I'm sorry. Let's do 4 and 16. I think that would be better. I think this kind of highlights for you how this is not going to be exact. Everybody's equation is going to be slightly different because you might interpret the graph just a little different, but that's okay. As long as they're close, then we'll be fine. So we've got 4 and 16, and then we've got, what are we going to do? 8 and 27, 7 and 25. How's 7 and 25 look for you guys? I think that looks good. 7 and 25. So here's my 2 points. Next, I need to find the slope. In order to find the slope, I got to do y2 minus y1 over x2 minus x1. And I end up with 9 over 3, which is just 3 over 1, right? That's my slope. After that, what do I need to do? I need to find my y-intercept. Well, for this, all I do is I just look at where the line is crossing. There's a 4, a 5, 4 and a 5 in between there. I'm going to say that's a 4. You might say 4.5, and that's okay. But I'm going to go with 4. That means my equation will say y equals 3x plus 4. All I'm doing is I'm trying to describe what's happening with these points. where if I wanted to predict way down the line here, way down the line, I could use this equation and plug in the information for 20 or 30 points down on the x-axis, and it would give me something like an approximation, and that would be close. Okay, it's for prediction purposes. Here, they're taking you one step further back, and they give you the scatter plot, or they give you the information, but you have to make the scatter plot first. So that's an extra step in the problem. So I'm going to go to 0, 2. I'm going to go to 1, 3.5. I'll do 1, 2.5, 2, 3.5, 4, 4, and 5, 5, and 6, 5. So now I want to, all right, so I've got my points on here, and now I want to draw a line. Let's see if I can go and figure out how to do that. I want to draw a nice line. Here it is. There we go. And I'm going to start way back here. I'm going to try and make it a nice slope. Okay. So one of the things that I'm trying to do is I'm trying to make it so that it splits the group. I've got 3 on top and 3 below. Well, it looks like I've got 4 below. So if I alter this a little bit, I could do pretty good. Now I'm moving everything else around. Okay, I'm just going to leave it where it's at. From here, now that I've got my line and my points and everything, I think that fits the trend pretty well. What I want you guys to do is I want you to find 2 points. I'm looking. I want to find a place like this where I'm at 6, 5. I think that's a great spot. That's a really easy point to put in there. And I need another good one. I think this one, 1 and 3, is really close. It might not be exactly 1, 3, but it's close enough for me. All right. Now, once I get 1, 3, and 6, 5, I can do my slope. My slope is going to be 3 minus 5 over 1 minus 6. So I end up with a -2 over a -5. So that's 2/5, right? 2 over 5. Finally, I look for my y-intercept. My y-intercept is right here. I'm going to estimate that. This is 2, this is 3. This is going to be 2.5. Okay? So when I write my equation, it's going to say y equals 2/5, or I could say 0.4 if I wanted to. 2/5 x plus 2.5. And that is the equation of my line. Some people might have a slightly different slope or a slightly different y-intercept. This is an estimation, but if I want to go down the road further, I can use 2/5 x plus 2.5 as a way of predicting where my next points will be way down there. All right, last one. We have the scatter plot. It's all set up. We need to find an equation for this trend line. And this one, again, is going to be an estimate. For one, I need 2 points. I need the slope, and I need my y-intercept. Okay. I know right here, my y-intercept, I'm going to estimate that. I'm going to say that's about 5.2. For my slope, I have to have my 2 points first. So let's look and see. I've got 3 and 6. That's a good point. And then I've also got, what I'm going to say is 7 and 7. 3 and 6, 7 and 7. It might not be exactly, but I'm estimating. I'm trying to make a good prediction. So 7 minus 6 is 1. 7 minus 3 is 4. So my slope is 1/4. My y-intercept is 5.2. So my equation is y equals 1/4 x plus 5.2. When I move down, I'll use my equation here to make some predictions. How much will the movie cost in 2020? Well, how many years down the road is that? It's 20 years down the road since 2000. So I do y equals 1/4 20 plus 5.2. And when I work this out, this becomes 5 plus 5.2. In the end, I get $10.20 as my future cost 20 years from 2000. In addition to that, when did the average movie ticket cost $6.50? Well, I could plug in $6.50 into my equation, 1/4 x plus 5.2, and I could solve that way. But I'm going to cheat, and I'm going to go the easy way, and I'm just going to look at my graph. When do I see the cost being $6.50? Well, here's right in the middle, $6.50. I'm looking at between 2005 and 2006. 2005 or okay, and that's about it. That's what as far as I'm gonna go. For you guys, you've got that worksheet to do. I hope that this video was helpful for you. This is not an exact science, okay? You guys are making a judgment. Judgments can be difficult. So trust your work. Go and try and finish up that worksheet, and when you come in on Monday, we'll go over the questions together. Okay, thanks, guys.